photosynthesis, generating fuel and electricity, manufacturing goods, raising kids, delivering projects. This diagram applies to a lot of things happening around us. Starting with the first Quik-Tech-Talk, the main theme has been the universal law of thermodynamics, the almost always increasing entropy rule. That is our lighthouse when it comes to understanding events around us and predicting what likely is going to happen next. And this reaction diagram is just one of many steps in that process. At the most fundamental level, this is also why we have matter in our universe, why we have quantum physics and quantum computers, and even why we are able to count things around us. This is the famous faces of a bubble chart. It was introduced by Jean-Paul Rodrigue, who was born in 1967 in Montreal, Quebec, Canada. Smart money purchases during the earlier stealth phase. Institutional investors begin to buy during takeoff. With increasing media coverage and word of mouth, the general public begins to invest, leading to a steep rise. After the delusion and the peak, everything falls off a cliff. This happens more often than many think, especially with new IPOs, but in general with many investment instruments. It's a cycle, really. It has three differences from our reaction diagram on top right. Bear trap, bull trap, and despair. They reflect human psychology's additional effect. Other than those, the two diagrams are almost identical. Another very similar diagram, right? This time we are looking at the Gartner's hype cycle template. The best time to invest is probably first half of the ramp between technology trigger and peak of inflated expectations. Between the peak and the bottom, though, shrinking demand and crowded supply might cause a lot of failures, especially among those who invested around the peak. After reaching the plateau, it is also possible to have cash cows producing stable income for those invested during the slope of enlightenment. Now, let's have a look at the recent past. There are many hype cycle charts released by Gartner. We are going to focus on emerging technologies hype cycle. We will just pick 4 examples. Speech recognition, close to reaching the plateau in 2009. Cloud computing, right at the peak. Augmented reality climbing, and quantum computing at the start. Let's fast forward 3 years. In 2012, speech recognition hasn't moved much. Cloud computing is falling fast from the peak, so is augmented reality. Big data appeared on the scene, probably following and benefiting from cloud computing's lead. And quantum computing hasn't moved much either. 2 years later, in 2014, speech recognition and quantum computing haven't moved much again. Cloud computing has already reached the bottom, augmented reality and big data falling fast this time. Let's fast forward another couple of years. We have reached 2016 and augmented reality reached the bottom. Quantum computing still slowly climbing, and others have already disappeared on the plateau's horizon. What we see here is, once the peak is crossed, the fall is usually fast. On the other hand, climbing and plateau phases might take some time. Another observation, we have time traveled from 2009 to 2016. At the end of a 7-year period, the cycle almost resets, with some exceptions maybe. Let's fast forward another 7 years. Now we are looking at the hype cycle for emerging technologies 2023. This was released last August, so the new one should be around the corner, if not already released. Let's remember, between the peak and the bottom, shrinking demand and crowded supply might cause a lot of failures, especially among those who invested around the peak. The best time to invest is probably the first half of the climb to the peak. Let's review some contenders on this one. In traditional machine learning, we usually train models on data that is collected from several sources like smartphones, sensors, and users. We bring that data together to a centralized server and train models there. In federated machine learning, multiple clients train models on multiple local datasets. For example, each client trains a deep neural network model using its own image database. Then, only the trained models from those clients, not the images, are shared together to produce a single large model. The most obvious benefit is cost saving by less data movement and faster model training. More on this in a future Quik-Tech-Talk with use cases and examples, I hope. AI simulation is the combined application of AI and simulation technologies. The goal is to develop AI agents, such as robots, and train them in simulated environments to solve real-life problems. Using AI makes simulations efficient and realistic. Using simulations makes AI systems versatile and adaptive, such as in a symbiotic relationship. I guess many has heard about the game Minecraft. It allows building and playing virtual environments with many possibilities. It could be considered a precursor to Facebook's metaverse, for example. Several years ago, Microsoft bought the company that developed Minecraft. Soon after that, Microsoft researchers started simulating reinforcement learning in Minecraft virtual environments to train virtual agents in this case. As you might have noticed, reinforcement learning is also an emerging technology on this screen, right above AI simulation. Using Minecraft is a very powerful approach in reinforcement learning, and you can explore the GitHub project online if you are interested. It was my first experiment together with my son on reinforcement learning, and if you have some Python skills, it's a lot of fun too. Another big potential for AI simulation is, of course, with quantum computing, which is the ultimate powerful environment for simulations. More on this in a future tech talk, Quik-Tech-Talk as well. Quantum computing will cause existing cryptography to weaken, even broken. Many governments, military and intelligence organizations, vendors, and large companies know this. They have already started investing in quantum-safe cryptography. They are proactively using existing classical computers, mimicking quantum computers to work in this area because quantum computers are not quite ready for this. And more on this in a future Quik-Tech-Talk as well. Similar to how we've seen big data following and benefiting from cloud computing in the previous charts, augmented FinOps can follow and benefit from federated machine learning, for example. Many times, the challenge for an organization is to predict new cloud consumption and development costs without historical data. In the absence of historical data in an organization, predictions can be made using models trained on similar environments in other organizations. That's very similar to how we described federated machine learning, right? In this and some other AI scenarios, AI augments FinOps. And now the big remaining question I have is, where are our flying cars?